Well, we have just finished dinner. My tummy's full, but it's time to get back to calculus. So, prior to dinner, we talked about the squeeze theorem, or the sandwich theorem, or you may call it the pincher theorem. But now what we're going to do is we are going to look more at some limits with trig functions. But what we will do in order to evaluate them is use known limits to find other limits. Oh, let me slide my fancy page. There. Okay. Now there are two limits that we have investigated pretty thoroughly using our graphing calculator. One of them is this first limit. Now this is the limit as x approaches 0 of sine of x over x is equal to 1. So we have looked at this limit and know that this is to be true. So I'm going to use this as a building block to find other limits. Now another limit that is very important is just basically it's reciprocal. Ooh, easy for me to say. And that is the limit as x approaches 0 of x over sine of x is also equal to 1. So using those two givens, let's see if we can use that to find the limit as x approaches 0 of sine of 5x over x. But actually, we're not going to do this. You're going to do that, because you have an example on your worksheet from notes that was similar to this. Now see if you can apply that. So find your answer, make a choice, and then come back for the result. So how'd you do? I hope you nailed it. So here we go. This is how it works. So I look at the expression. I notice it's 5 of x over x. But in order to use this limit, I need the sign quantity to be the same as the denominator. So in other words, I need this denominator to be 5x. So what I'm going to do is I'm going to multiply both the numerator and the denominator by 5. So basically I'm multiplying by 1. And when I do that, I have the limit as x approaches 0. Now you always have to write that limit as x approaches 0 each time because it doesn't go anywhere until I actually take the limit of 5 of sine of 5x all over 5x. Beautiful. This is the piece I want. So what I'm going to do is I'm going to use my properties of limits. So the limit as x approaches 0 of 5, which is a horizontal line, times the limit as x approaches 0 of sine of 5x over 5x. So the horizontal line 5 always will have a limit of 5, no matter what constant you're approaching. And then sine of 5x over 5x has the limit of 1 as x approaches 0. So the solution is 5. How did you do? Did you get that right? I hope you did. Okay, now let's move along. Fancy paper switch here. Dun, 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 dun. Beautiful. Okay, now this is another limit that is going to be a limit that we will know very well. But before we know it, we got to prove it. So let's do some math here. Well, algebraically, the first thing I would do is try to substitute. What's cosine of 0? Bing, 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 bing. Cosine 0 is 1? Right. So we get 1 minus 1 is 0 over 0. 0 over 0 is the undeterminate form, which tells me that I have to keep going. Don't give up. Persevere. Show grit and tenacity. Okay, so next then, after I substitute, now I'm going to try to rationalize. Oh, that means multiply by the conjugate. Well, what is the conjugate of cosine x minus 1? Well, of course, it is cosine x plus 1. Now, I'm not sure if this is going to get me anywhere, but you know what? I'm going to try. And if it doesn't work, I'll try something else. So now I have the limit as x approaches 0, and I multiply the two binomials. It's a difference of two squares. So I get cosine squared x minus 1 in the numerator. Oh boy, that makes me excited because I kind of know what that means. X times cosine x plus 1. Do you know cosine squared x minus 1? What's another way of expressing that? Do you remember your Pythagorean theorem for trig functions? Sine squared x plus cosine squared x is 1. So therefore, the numerator has a value of sine squared x. Now, why does that make me happy? Because it just breaks up the expression a little bit, and it might give me a pathway to a solution. Ooh, do you see sine of x over x embedded there? I do, and I know that value is 1 as x approaches 0. So can I rewrite this expression so I have sine of x over x? Well, we know sine squared x is sine of x. Another way of writing that is sine of x times a quantity sine of x. So then what we can do is we can rewrite this fraction as sine of x over x times sine of x over cosine x plus 1. So just a little bit of fraction work. So the limit as x approaches 0 of sine of x over x, whoo, that is 1. Okay, I'm writing it out as you can see. Sine of x over x times the limit as x approaches 0 of sine of x over cosine x plus 1. Okay, so sine of x over x is 1. Now what's this limit? Let's substitute and find out. What's sine of 0? It is 0. And then 0 over cosine of 0 is 0, so I get 0 over 1, which 0 divided by 1 is 0. So the solution is 0. So that means that this limit here has a value of 0. Very important. Highlight that fact. It's a good one. Okay, now what I want you to do is using this fact of cosine x over x, limit as x approaches 0,